Hi, I'm back, and I'm just going to try to convince you that changing the amount of a solid or a liquid doesn't change its concentration. You might like this or you might think this is really weird, but I'm going to do it. I got almonds. I got 8 of them in a square. The concentration of almonds here is the number of almonds uh, in the space that they're confined in. Okay, so typically we call that a volume. I'm just limiting it to an area here. I hope you can live with that. So what I'm going to say is that the concentration here are 8 almonds per square. And you can see the size of the square there. Okay? What if we take half of them away? Now there's only 4 almonds. If the almonds were a gas, they'd spread out and they'd take up the same amount of space, a full square. And the concentration would be 4 almonds per square. Okay, but almonds don't do that. Solids don't do that. What they do is they take up less space. So I'm going to fit my 4 almonds into a much smaller square. So here the concentration is going to be 4 almonds. Okay, and I'm just waving my hands here. I'm not going to get a ruler out. But this square is half the size of our standard square that we used with 8 almonds. When you do that math, the concentration of those 4 almonds is 8 almonds per square. Because I'm saying that this square is half the other square. So I also like to think of it, if you cut a brick of butter in half, the concentration's gone to half a brick of butter divided by half the space. It's still the concentration of the butter you had before you cut it. So this is why we don't include solids or liquids in KC calculations, because changing the amount changes the volume proportionally. Okay, concentration is the amount divided by the volume. So for solids and liquids, if you cut the amount in half, the volume becomes half. Half divided by half is going to give you the same concentration as before.